All right, good morning and happy Saturday. I just missed the bi-weekly contest, so I was a little bummed when I found that out, but I'm going to do that virtually, which is second best, and that's good enough, I suppose. So, yeah, this guy just ended, and I'm going to jam on it virtually. So, let's see. Hold on, I want to do this. I might have to refresh the page here. Okay, here we go. Yeah, bi-weekly contest 129 that just finished 3 minutes ago. I'm going to do this virtually, which isn't quite the same as a real contest, but it's good enough, whatever. Let's start jamming. It's good practice. What the contest has ended? Did it start or I hit virtual? The let me try this again. Virtual, start new. The contest has ended. All right, I think we found a bug on LeetCode's webpage. So, all right, whatever. We'll just thought that it would start that. Come on, this is strange. I guess I've never tried a virtual contest right after the real contest ended. So, oh, here we go. Try this button. You already have one going, but it says the contest ended. All right, whatever. It's 9:04. This isn't working how I'd expect it to, but we'll just do it. Right. It's 9:04, so we should end at like 10:34. Start a timer so you can keep it Pomodoro. I'll start my timer on my phone. The clock is ticking and we're keeping score. Here we go. It's 9:04 in the AM and it's time to shine. Here we go. This guy. 9:04 AM. Let's see what we got. Okay, black and white. 2 by 2 is true. This is stupid, isn't it? Oh, what the heck? Did I misread this? Change a color of less than one cell. Okay, whatever. It's kind of silly, but whatever. Whatever. All right, so here's the game plan. Right, just go through. See, it's a 3 by 3 cell, right? So 3 by 3. So we need to look at the middle each time. Let's just do a brute force, right? Brute force solution of the game plan. So for each IJ cell on the top corner, right? And see if we have three. If we have three of the same color. If so, return true. Otherwise, return false, right? Okay, so that's the game plan, and that took about 1 minute to read and come up with. Implementation begins now. Implementation begins. Let's see what happens here. This is our array, and then it'll be a 3 by 3 array. Let's just do this. M equals 3, N equals 3 for the rows and columns correspondingly. And then for each ith row, I n range n minus 1. So go from 0 and 1. We're not going to do 3 because it's not a top left corner, right? Same logic for the column, right? Don't go to the endpoint inclusive. And then we'll say black equals the set of values, ij. Let's see, black and white, how about? I want to express this. Let's see, maybe I'll create a function. It'll just be a lambda for each ij cell. I can turn. Actually, I don't know. Maybe that's not an indirection. It's helpful. Let's just do this. Black and white are just counters, right? B and W counter, right? And then we'll just say Right through this. Let's just do UV, whatever. UV pairs. How about UV and the cell IJ? I plus 1J. Oops. J plus 1, and then I plus 1, J plus 1, right? So those are your 4 cells. And then we'll do this. Black and white are, yeah, we can just do counters, right? Whatever, we'll just do this. If A sub U sub B is that, then we'll do B, actually, these would just be integers then, right? Black and white. B and W 0 and 0. Okay, so B, which is black, plus equals this guy as a predicate equals the B. And then white, it's the integer value, so U sub B is equal to W. So if those predicates are true, be incremented. If B is greater than or equal to 3, right? Or W is greater than or equal to 3. And by the way, this does take some sense, it makes sense, I think, to write values to the left and right like this, because you can intuitively see, based on the code, what threshold we're exceeding. Since we read from left to right usually, and we think of monotonically increasing values from left to right as well, I think it makes sense to reduce our cognitive load by writing code in the same way. And I thought this was weird at first. It does take some psychological flexibility to adapt and change to new things. Like most folks, I think, probably write this way. And I would have been part of most folks, I think, before I started LeetCoding and reading Barnes Drewstrups, the dude that wrote C++, he writes code in this manner, not in this way. But again, it does take some psychological flexibility to adapt and change our ways. So you can see a lot of people on LeetCode only code in one language, so not very many polyglots, unfortunately. But I highly encourage you all to be polyglot, think outside the box. Right? Who needs to go with the crowd? Since when does popular opinion know anything? Okay, I'm rambling. It's 10 after 9, and that took about 5 minutes for the implementation. My implementation ends. Implementation ends as in ends in acceptance with 5 minutes, 6 minutes total. Yay. Okay, so that worked, and that seems good enough. Whatever. Let's do this. Write this in a couple different languages. And usually it's when I take a break and look at these things in a different language that actually have these kind of aha moments. So it's always good to get a different perspective on things, I think. You know. Let's see. Oops. Yeah. So my different perspective I like to look at is the Kotlin, right? The JavaScript, the Rust, and the C++. Okay. Oops. Using VC, the vector of char. And this is our 2-dimensional array. Just shorten this up a little bit. Here's our input array A. M is the number of rows, N is the number of columns. And fonts at the end here, and I will find what we're looking for. And for each ith row, right? Go through those guys. And I'm purposefully adding +1 here instead of doing -1 for C++ because a lot of times the size is a U size is a size T. So if you subtract 1 from 0, you end up with a gigantic number. So you have to be extra careful, I think, with C++. C++ is a language that'll let you get into trouble. So it's very important to be disciplined and strict when writing it. Okay, let's do this. Black and white. This guy 0 and 0, basically just integer values that we increment. Okay, so would you structure pairs here? So using a pair as a pair of intents for our IJ cells, and our UV offsets will be pairs. Oops. There's our vector pairs, right? So pairs, oops, pairs. So we use the initializer list of this guy. So I, J is one of the cells. I +1, J is another cell. I, J +1 is another cell. And then I +1, J +1. And actually, I was thinking maybe I should take a little bit of a break and reconsider to make this easier. Because this center cell has to be the color the other 3 cells are. Right? Or no, it doesn't necessarily have to be, right? No. It does make it more complicated than it needs to be, right? Keep it super simple if we can. Okay, so let's do this. Squigglies here. The predicate is the array cell UV is equal to B, and this guy is implemented, right? So that's black, and this guy is white. So B sub B is equal to white. Terms if B is greater than or equal to 3, or white is greater than or equal to 3, or return true. And nothing too fancy, right? Looks good. All right, that's legit. Good enough. Let's do Kotlin next. It's 9:15 in the AM. All right, here we go. M is an integer equal to 3, and is an integer equal to 3 for in 0 until, just gonna do until 1, right? So we don't need these, right? Get rid of these. For j and 0 until 1. Also, we get down here. For UV in list of pairs, pair IJ pair +1J, J +1, pair I +1, J +1. Oops. All right, do black and white. Black and white will be our counters, initialized to 0 each. If A sub U sub B is equal to, let's do this, B plus equals this guy is equal to black +1, otherwise 0. White plus equal to if A sub U sub B, white 1, otherwise 0. And then we'll return just this, return outside this for the right return. Oops, if I wonder if I actually have this conditional inside the for loop. We can probably pull it out of the for loop for the other solutions. Yeah, that should be Kotlin. Big money, no whammies. 9:15 to 9:17, about 2 minutes. All right, that's cool. And then let me double check my other solutions real quick. I want to return outside of the loop. This is more efficient that way, I think. Yeah, that's good enough, whatever. Okay, C++, take this outside of loop as well. Makes it look better. I think like this, oops. I see this for loop is only doing one thing. Try to keep things super simple. Keep it super simple. Otherwise, I'm not going to understand it. Okay. Do JavaScript and Rust, and then we'll move on here. Let's see, JavaScript. All right, it's 9:18 a.m. Grid, oops. Check grid. I equals 0, I is less than 2. I'll just hard code it, whatever. False at the end here. 0, j is less than 2. Will be implemented. Black and white will be the pair 0, 0. B of ij, I plus 1j, ij plus 1, I plus 1, j plus 1. Guy being printed for blacks. This guy will be incremented whites. If black exceeds 3 or white exceeds 3, we'll return true. All right, 9:18 to 9:19, about 60 seconds or so. So that's cool. Oops, there's JavaScript. I'll just do let instead of bar. For ES6 syntax. Okay, and then the rest will be next. All right, do for I in 0 until 2 non-inclusive. I'm just do 1 inclusive, whatever, it doesn't matter. Turn false if we get down here, or j in 0 until 1 inclusive. Right, mutable b, mutable w equals 0, 0, for uv in the vector of these pairs, right? ij, I plus 1, j, j plus 1, I plus 1, j plus 1. If a sub u should be is equal to black 1 was 0. This guy is equal to white. Then 1, 0. If black exceeds 3 or white exceeds exceeds 3, right? We'll return true. Okay, let's see what happens here. Rust is one of those special languages that usually gives me a hard time. Usually fail forward to get that thing working, but that time maybe we got a little bit lucky. And that is fairly simple. Okay, add some tags and let's move on here. C++, Python 3, JavaScript, Kotlin and Rust. Okay, here we go. There's a piece. Oops, I didn't. I'll put a description here too. Hold on. Let's do this. This is our code. This is our game plan. Yeah, I guess it's kind of silly, but whatever. Iterate through each candidate. Oops. Candidate 2x2 square. And each square's top left ij cell to accumulate count of black and the white cells U of B return true if and only if the quantity, I guess the count of black or white cells meets or exceeds 3. There we go. That sounds good. Good enough. Okay, let's move on. It'd be cool to have enough time there for Q4, which is a lot more interesting than that question. The count 10 is still not working. It's a bummer. Okay, well, we're about 20 minutes in and it's Q2 time. 20 minutes, right? Let's see. Q1 took about 20 minutes. And it's 9:23 in the AM for Q2. There's our array. Okay, let's read this. Right try. What the hell is this? And these questions are stupid. What is this? I didn't come to LeetCode to do crap little questions like this. Come on, really? Right triangles. Okay, here the ones are zeros. Okay, yeah, I don't know. All right, whatever. So hoping for more of a challenge in this. So this is like the same exact code almost as the last one, isn't it? Come on. We'll do what the fuck, LeetCode? This sucks, but whatever. I'll channel it. M and N are rows and columns correspondingly, right? Okay, for I in range up until the end here. These would be your top left corners. T would be our total count. We'll do the count of ones then. The same exact code that I'm writing. I don't know, maybe I have an opportunity to write better code. I want to keep it simple though, right? So it seems simple enough. Just add up, right? Jeez, we'll just accumulate the count here. Let's see if this count, some of this thing. This in here. Oops. From A sub U sub B, for A sub U sub B in that, if it exceeds 3, or no, if it's exactly, wait, hold on. The 3 elements do not have to be what? Same row. Maybe I misread this. All ones, yeah. Why is there? Yeah, okay, there's one here and there's one there. Yeah, as long as there's 3. So what is this? A collection of 3 is a right triangle. If one of its elements is the same row, the other elements is the same column, and the third element. That's just stupid, isn't it? The 3 elements do not have to be next to each other. What the hell does that mean? Man, I sure am complaining a lot, so maybe I just need to shut up and start coding. All right. Oh, okay. So this one, I see. Okay. Now I see. Okay. So I did misread that. Originally, I was thinking like, dude, this is stupid, right? Okay. So this is actually a little bit more challenging in that I've read the problem statement and it is a little bit more challenging. So I was wrong. Oops. Oops. I was wrong. This is more interesting than Q1. I just misread the problem statement. Okay, so it's 9:28. Just try again. At least I didn't go too far down that rabbit hole. Okay, so how we want to approach this, right? They don't have to be right next to each other. So this example shows that there's a quantity to the right and the quantity down below, right? So the game plan is this, right? Game plan per IJ cell, we'd want to know the quantity of ones to the left, ones to the right, ones up, and to the right, left as well, right? Up, down, left, and right for each IJ cell. Ooh. Yeah, so this is interesting. Okay, so it's 1,000 by 1,000, so we can't just do brute force looking for each IJ cell. Right, so we do need to pre-process it from left to right, right to left, up to down, and down to left, down to bottom, right? So let's do that, and up, down, left, and right, pre-process. Does that sound right? Like each row, no. Yeah, okay, I think that makes sense. Pre-process, prefix sums, prefix, suffix sums, whatever you want to call it. Right, and then we'll know the quantity above, to the left, and the right angles for that would be the minimum of this one and that one, plus the minimum of this one and that one, minimum of this one and that one, minimum of this one and that one, right? Okay. So I can see it in my head, that makes sense. We'll still use the T as a total, and then we'll pre-process up, down, left, and right. I'm sure that'll work, right? Okay. So we do up to down and left to right at the same time. Let's do this. Down, left, right can be a grid as well. Accumulate the quantity of up, down. These are just a deep copy of the input matrix A. Brian range, oops, M. Right, up and down, we'll go through those. So it'll be the opposite way. Or just call it K. How about K? K will be M minus 1 minus I. So it'll start at the bottom and go up as I goes down. Then whatever I call it. K's fine. Okay, and then up will be the ones above it. Actually, we'll do it from 1 to M. So I have to check the bounds. Up sub I through and the K. Wait, hold on. I throw. Oh, dang. Okay, so we do need to go through this per column then, right? If I say per jth column. For each column, we'll do the ups and downs, and then for each row, we'll do the left and rights next. That's okay. Up, be the guy above it. Down, move the fellow below it. All right, so that's good. And then we'll do the left and right next. Copy of that guy, copy of that guy. For which I row, go through each jth column. All right, to do left and right from 1 to n. K will be, so J will be this guy, K will be that guy, and left and right correspondingly. So then it's equal to n minus 1 minus j. So K will be the rightmost column, J will be the leftmost column. And then so left I sub j. It's incremented by left, and then the guy to the left of this fellow. Right I sub j's. Right sub, oops, it's actually I sub k, right? I through k plus 1. Okay, so those are recurrence relations, right? Simple prefix sums from left to right, right? Down to up, and then we should be able to accumulate the total now. So let's go through ij cell. Oops. J in range. Okay, so if a sub I sub j, then we know it has a potential for up and to the left, up and to the right, down and to the left, and then down to the right. Those are the four directions, up, down, left, and right, right? So we need the minimum as the bottleneck for each of those four. Minimum of up and left. So up and left will be ij above and to the left. Okay, so actually, yeah, we don't want to go from 1 to n minus 1, 1 to n minus 1. So we don't want the borders. We don't have to do out of bounds checks. Right, okay, I think that makes sense. And then for each UV pair of those then, right? So for UV, and we can use whatever we want, X, Y, UV, IJ, as long as like we can keep track of what's what, right? More consistent. It doesn't really matter. Okay. So for UV and the one to the left, up and to the left will be U will be I plus 1, and to the left will be J minus 1, right? Up and to the left, do up and to the right, do down and to the left, down to the left, and then down and to the right. Okay, so the first will be I guess, let me see, how do I want to do this? Up and to the left, be the left. I have to meaningfully consider left and right as well, though. Right, so let's just do these one at a time. So t plus equals up and to the left would be the minimum of, do up and to the left first, up and to the left. So up, and then to the left. The minimum of that one, right, up and to the left. The minimum of up and then to the right. Okay, and then the total will be the minimum of down and to the left, down and to the left. Oops, this one's to the, wait, this is down. Wait, this foot's down. This one down, okay. And then to the left. And then J minus one. The minimum down. And to the right. Right? Okay, let's see what happens. It is 9:13 or 9:23, 9:28. It's 9:38 right now. 9:38 in the AM. Let's see what happens. Run our code. Should be 2, 0, and 2. Uh-oh. 18. Holy cow. Okay, that's not right. Oh crap. Okay, this is actually a lot more complicated than I actually wrote it too. So when you go there, then you have to check out. Oh dang, okay. Actually, dang, okay, I wrote this wrong too. Oops. Thought about this wrong. Oops. I thought about this wrong twice now. This one's like subtly tricky. Okay, note to self, it's always a good humbling experience to do this because it's a reminder that I often do solve the wrong problem. I'm gonna grab some more coffee and be right back. All right, full cup of coffee. Start jamming again. Dang. So it's 1,000 by 1,000, but for each of these, you want to go there and then there. So dang. I guess we do two at a time. Quantity. Three and two. Looking like, how can we consider this maybe per row and column total? Make life easier on ourselves. So we need two or more per cell. 1, 2 in order to make it 3 and 2. I wonder if it's as simple as that then. Based on anecdotal evidence, it does seem to suggest that we can just accumulate the sums, right? And then return the minimum of whatever exceeds 2, 2, 1, 1, 3, 0, 1, 2, 1, 1, 3. Two. It is sick. I wonder Am I really that far off? Or maybe I am somewhat right, but my quantity that I accumulated is way higher than I'd expect though. What's going on here? It's a good reminder, when people fast is slow and slow is fast, so it's good to slow down. See, okay, maybe I was kind of close then, right? So the minimum of this and that, which I add on to it. Down and to the right. So this guy down and to the right, one, multiplied by two, one multiplied by two. Ah, it's not the minimum, is it then? It's the multiplication for ij. So I wonder, yeah, maybe I didn't misread it so bad, but I just did a miscalculation. Right now I'm thinking maybe I don't need to go way back to the drawing board, but there's left, yeah, there's none to the left or right or down, then that'll take care of itself, right? I need to look more closely as well. Go slow and look more closely. It's 9:44 in the AM. Oops. 9:44. Indentation. Yeah, let's do some indentations. Oops. Times that. Oh, holy cow. Okay, that's like even a larger number. Holy cow. Okay, I'm way off. Man. This example. Really? This is a 90. Holy cow. Hmm. Yeah, I think this does make sense, right? So let's just print these things out. What's going on? I don't know. Look more closely. Like, stop thinking and start looking. Right, right, up, right, down, right, left, right. I just print them out and see what happens. Right. Yeah, just left and right aren't. Where did the left and right go? There they are. Hold on, left and right are populated here. Really? Up, down, left, and right are. Uh, oh crap. Okay, I didn't copy these right. These are a shallow copy instead of a deep copy, right? Yeah. Copy of each row for a row and then okay, so I'm accumulating the values on top of a shallow copy, right? This is what I want. Okay, so do a deep copy of each row in the input matrix A, then accumulate the sums, right? Okay, okay, well, at least I passed a couple test cases, right? It's always nice to see a little green. Okay, so case three, or what is this? Case three, I'm returning zero. We expect two. So case 3. Let's go here for case 3 then. Loosely. This guy's up. Makes sense. 1, 2, 3, 0, 0, 0, 1, 1, 1. Looks good. That's expected. This guy's down. Down's perspective. That looks good. Okay, this guy's from left to right. Right, left to right, left to right. That looks good. And this guy is from right to left. Left. That looks good. Okay, so what is going on here then? This times that. Should be 1 times 2 for the first one, isn't it? Down and to the right. Down and to the right. Down. To the right. That's right. So the top left cell, IJ 0, 0. Up, down. Down should be 2. Left and right should be 1. The heck? Down and to the right. Hmm. Well, let's just print it out. Up. Let's see. I'm gonna print IJ. IJ. And up is up. 1 above I. Same J. Down. Oops. Down is down. So I plus 1 is a J. Right. Left. Same I. J minus 1. And then right. This 1. Okay. Let's see what's printed here. See what's going on. What the? It's not. Okay. All right. So I can't do the bounds. Okay. So now I know what's the problem here for Q or case 3. Right. We do need to go through each IJ style. Right. We can't skip the top left, bottom, and right borders, but we do need to consider if we can go to the left, up and to the left. This guy, if it's in bounds, right? If that guy, then this guy's in bounds as well. Otherwise, 0. Okay, this is pretty verbose, but it's kind of interesting. I don't know. I'm hoping for a better Q3 and Q4 experience. Okay, let's see what happens here. I think we fixed that up after some debug printing and it's a pretty obvious mistake. Uh-oh, index is out of right. Oh, okay. Our debug print is still no good. Good to validate that I did these right now. So I had a couple problems. One is the shallow copy, right? And then I was just adding on top of the same thing over and over again. Two, I forgot the bounds. We need to check this first row, first column, as well as last row, last column, and such. Okay, so 953. Yay, it's accepted. So that's cool. I didn't backtrack too much, but originally I thought, man, this is stupid, right? Okay. Then I'm like, oh, okay, it's a little bit more interesting in that we use dynamic programming for pre-calculations and prefix sums from up to down, left to right and down to up and right to left. So that's cool. Well, holy cow, this code is very verbose. Hmm. Well, we are going from up to down to left to right, and I could maybe put this in one loop instead of two. Oh, I had to consider the bounds checks though. Let's see what the code looks like. And might as well, before I say no, because we each have a negativity bias, might as well just take a look at it, see if I can fix this up a little bit, put this all in one for loop. I think that might make the cognitive load less, right? So we're all doing it all at once, but let's see, case. Yeah, I'd have to come up with a different value than K for this guy. It could be K and L, I guess. -1 minus J. This is only good if 0 is, let's say, I -1, right? I is in bounds. Y 0. If K plus 1 is less than another 0, then L would be used in case of K here. Oops. Blah. If this makes things better or worse. But I am aiming for simplicity, right? So okay, same deal. I think it's a little bit simpler, right? Just one for loop instead of two here, and then right, here's all our pre-calculations. And then this is just going through it to use those pre-calculations. Yeah, I kind of like it more. That's cool. Let's do this. That's a lot of typing. Holy cow. Okay, let's see. So these are my breadcrumbs for how I got here, right? I think these are helpful. Right, well, not like perfect, and this isn't what I first came up with. Right, so I failed forward and adapted, read it wrong the first time. I thought I read it wrong the second time, wrong, but it was actually right the second time. I just needed to write the code properly, that I forgot to actually took a deep copy of each row, then put matrix A. So I was accumulating the sums for the prefix sums and suffix sums wrong from left, right, down, up, down, and right and left. Right, so a couple bugs, but whatever. Breadcrumbs for how we arrived here. Right. I did get accepted, right? Without any bugs, so that's cool. All right, this is the game plan and then the code. Starting with Python 3. Python. Okay, grab this guy. It's a decent enough solution, right? Nothing too fancy. Then we can describe it here, what we did. In order to avoid TLA, form prefix suffix sums in each cardinal direction. That is up, down, left, and right. Right, and then let's see, pre-calculations. Calculations of the prefix and suffix sums in each cardinal direction, and then for each, oops, and accumulate the total T right triangles by considering, right, considering each direction's limiting factor. For up, up and to the left. This up and to the right. Down and to the left. A little arrow here, right? So you can see the mapping of words to code. Let's see. IJ cell as the elbow, elbow. That'd be each right triangle. No, what are you going to call that thing where it meets the elbow? What do you want to call that? Right angle, the right angle. I mean, I guess the side as the position of the right angle coordinate, right? Right. And the 90-degree, right? 90 degree. Right angle. Point of each, right? Basically like that part, right? Right triangle. Okay, so accumulate the total T right triangles by considering each IJ cell as a position on the 90-degree right angle point of each right triangle. For each direction's limiting factor up and to the left. Right, will be this guy. Up and to the right. And then, yeah, down and to the right. Okay, we'll just grab these. So you can see, obviously, from each IJ cell what we're doing. Mapping code to words. Oops. Okay, so that's that. Right, up and to the left, up and to the right, down to the left, down to the right. It's kind of cool how that almost looks like a staircase. All right, whatever. I am running out of time, so we're at 58 minutes of the contest, and I want to jam on this in the other languages, and we'll post this at the Art of Dynamic Programming, which is my meal ticket to the Fang. So I think it's cool. Oops, hold on. Oops, hold on. Let's see. Grab this guy. Into you. Hopefully this is helpful for others because this took me a lot of time to learn, and I guess I'm still learning it. Good JavaScript, do Kotlin, good practice. Oops, hold on, let's see, Rust. Oh, I don't want to go way down here. It's like way down here. These are my breadcrumbs. Okay, I'm gonna be here. Rust, C++. Okay. Let's do C++ next. It's 10:04 in the AM. Sometimes integers. It doesn't matter. M and N are the finality input array A's, rows and columns correspondingly. Sizer. Oops, I'm gonna do that KK. What the heck? Total is gonna be that guy. I have to be careful with C++ because unlike Python 3, it does not handle large integers well. All right, this thing will overflow. Yeah, I'm gonna grab some more coffee. Be right back. Hey, Shelby. What's going on, partner? You need to fit the partner? Okay. Now come stay with you. Okay, let's finish this up. Let's get going. All right, we want to create a deep copy for left. Oops, up, down, left, and right, right? Up, down. And thankfully, C++ will do these deep copies for us, unlike Python 3. So each language has its pros and cons, I suppose. Right, we'll accumulate these sums and then do the same thing pretty much. Well, I should mention the rule of product, right? Be the rule of product. In combinatorics, that is a fancy word for counting stuff. Oops, I don't want to go on to the next question yet. The rule of product basically will, yeah, just multiply things, right? Okay, anyhow, look up on Wikipedia. I don't need to be spoon feeding folks, right? We each need to be responsible for feeding ourselves. Right, so then for each ith row, and then for each jth column, we'll have K and L. K will be the bottom row, L will be the rightmost jth column. Not to be confused with the cardinality direction, right, of left. This one's here. Oops. K is n minus 1 minus I. Similarly, L is j minus 1 minus, oops, n minus 1 minus j. L, K and L, I and J. Actually, let's just call these things U and B. L makes me think left, right? Yeah, it kind of does matter, right? We'll both be consistent if we can. Turn the total down there. So that's that. Okay, so then up sub I sub j plus equals, if there is up, right? Right, then up sub that guy. Oops, question mark. Y0 down. This one is less than m. If so, then down sub I plus 1 sub j y0. Left sub I sub j plus equals 0 I to the left 0 is less equal to j minus 1. If so, we'll take it. I sub j minus 1 y0. Right sub I sub j is equals j plus 1 is less than n. If so, right sub I sub j plus 1, otherwise 0. All right. There's our pre-calculations, right? And then we'll go through this loop again. Oops. 0 is less than m. All right, then put some squigglies around this guy. Okay. T plus equals. We have a left, right? It's in bounds. We'll take it. Right, left. Or up and to the left, right? Up and to the left. And to the left. Oops. It's in bounds, right? Up and to the left. Then we'll do up multiplied by to the left, right? L sub I sub j minus 1, otherwise 0. Up and to the right. Up. And to the right. All right, then we'll do down. It's in bounds and to the left. All right, then we'll do down. To the left, oops, left. All right, and then we'll do down and to the right. It's in bounds, right? Down. Oops. And then to the right. Okay. This times that. Ooh, I think these might need to be a long. Now that I think of this. The safest thing would be to make it a long, or you multiply, but it's only 1,000. No, no, yeah, it could be 1,000, so that should be fine. 1,000 times 1,000 is 1,000,000. As long as t is a long, we should be good. Okay, it's 1013, so that took a while to write. Oh crap. Okay, it's okay. Accidents happen. Do not berate self. Okay, it's 10:13 a.m. and something's busted. Holy cow, okay, it must be going out of bounds. Up, down, left, right. Oh crap, I'm not even doing this right, am I? No, I'm not. Up, down, left, right. Down. Be based on you. Left and right based on V. Okay, and then what's going on here? Up and to the left. Up and to the right. Down and to the left. Down and to the right. It looks good. Like, what am I missing here? Dang. It's busted. Well, this kind of sucks. Whatever, I guess it's good practice. These are size T, but or at least one. What am I missing here? What am I not seeing? Divide and conquer. I don't know, is the bug here, the bug there? It's being here then, isn't it? Let's see. I mean, this should be fine, right? Return 0. Does the bug exist in the pre-calculations and this, or only pre-calculation? Okay, so the bug must exist only in the pre-calculations. Okay, so what am I missing here? That's fine. G minus 1 is to the left. G plus 1 is to the right. There it is. Hey, boo. Son of a. Okay, well, at least I found it, right? That's cool. Oh, no, wait, it's still wrong. 4, expecting 2. Okay, well. 8? Holy cow. Really? Wonder what the heck is going on? What the heck is going on? Mm. Hmm. Well, more certainly it is a lot of typing, so it can be very error prone, right? As clearly demonstrated. Hmm. Yeah, let's do this. For each row, oops. Each row. And up. I'll be in, row not in, no string, iterator. By the way, no one writes C++ code like this, right? Not the row. But this is the way that C++ is intended to be written based on what I've read from the author, the John Strustrup fellow. And he tried to create iterators as a standard way of doing things because C++ does CPU prefetching. So if you write the C++ code using iterators properly, then you get unlimited L3 cache for those few souls who care. All right, whatever. I have no idea who's watching these things or if you care. I think this is pretty boring to watch, but whatever. Down left and right is use and validation of, oops, the precalculations, right? And they should all be a copy of A here, but then they should be populated. By the time we get down to here, up, down, left, right. Looks good. Am I accumulating too much then? The heck? I don't need parentheses around this thing. Getting confused. It looks okay, right? And the pre-calculations are correct. Up and to the left, up and to the right, down and to the left, down and to the right, right? Let's see. It's kind of a stab in the dark. All right, let's get back to this and let's just stop thinking and look. Is that a good strategy? Rich IJ said, what is T? To the left, up and to the right, down and to the left, down and to the right. Yeah, it looks okay. Let's see what's going on. IJ is IJ. They just give us some clues what our total is. And I should be able to keep track of what point the total is exceeding our expectations. What the heck? 4 on 1. J 0, 0, 1, 0, 2. There's a total of 1 here. Oh, I see now. Yep, that makes sense. If not dates of I sub j. That's what I missed. Continue. That should do it. Okay. Big money, no whammies. Oops, I should have printed that out. Oh, TLE, really? Maybe it's TLE because it's printing, right? So I probably should have got rid of, oops. I should get got rid of that debug print. Stick this in here. It's whatever. Without that debug print, I'd expect it to be accepted. Man, this took 20 minutes. Holy cow. That's good practice, right? You see, in about 20 minutes. Yay. Plus 1 bug. All right, so I had a typo, I and J intermixed, and then forgot to erase cout. All right, so that TLE down large input. And let's see, it says 120, an hour and 20 minutes I'm in right now. And this one is just taking forever to type. Like, holy cow, it's just so error prone. It's really easy to make a little mistake, right? It's a good humbling experience. Keep my ego in check, right? Let's do this. This might just be a 2-question contest because I'm gonna try to stop around 1 hour. In 30 minutes, just like a real contest. Right? I try to do it virtually. Okay. M and N are the bounds of rank array A. See if I can get this done a little bit faster and more accurately. JavaScript. Turn our total T here at the end. Let's see, and then I want to copy each row of the input array A into L. Up, down, left, and right, right, left, up. Each row. We'll just spread it, right? It should be okay. For deep copy, right? Up, down, left, right, up, down, left, right. All right, let's do these calculations to reduce the asymptotic bounds. So we don't TLE. This will be U. The youth row corresponds with I in reverse. It's going to correspond with J in reverse. Right, and we'll do the calculations. Up sub I sub J. Oops. I sub J. Up is in bounds. If so, add it. As we want. Down. Using U. U plus 1 is less than M. If so, down to U plus 1. So J. Right, left. This one is in bounds. Right. B. Okay, those are our pre-calculations. Go through and use them now. Oops. Okay, that guy, and then P plus equals up and to the left is in bounds. If so, I'll do it. Up, left. Up. And to the right. Down. And to the left. Oops. Down. And to the left. Oh. And to the right. Okay, let's see what happens here. 10:25 to 10:30. Ah, dang. Oops, I remember what I forgot to here, right? Evasive velocity needs to be set. Right, we'll do this stuff. Just get rid of these quickly, whatever. Looks good. Good enough, right? See what happens here. Yay. Okay. It's accepted. Holy cow, this is taking forever to write, but at least writing that one was a little more accurate. Okay. I'd say accuracy is more important than speed because I end up wasting so much time having to debug and look through the code. Right. So a good reminder, go slow. In order to go fast, up is a, oops, a dot map each row. It dot copy of. Grab this guy. Left, oops, left and then right. Line range 0 until M, or J and range 0 until N. Right, we'll do our pre-calculations here. U will be the corresponding row from the bottom. Similarly, V will be the corresponding column to the left, to the right. Right, okay, then put a T here at the end. T is long. Okay, so up sub I sub j plus equals if I plus 1 is less than, oops, I minus 1, right? Minus 1. It's in bounds. Up sub I minus 1 sub j, y 0. Down sub I sub j plus equals if this 1 is less than, oops, this guy's going to use u. All right, u plus 1 less than m. If so, down sub U plus 1 sub j. Oops. Otherwise 0. Left sub I sub j. Left to be j minus 1. Right sub I sub j. J plus 1 is less than n. Good reason. I think, yeah, everyone is really nice here. Okay, anyhow, just trying to daydream a little bit. We got a few seconds left till 1 hour and 30 minutes on my clock, so I'll just finish up Kotlin and call it a day. It's good to take a break, right? I'm a human being, not a human doing, so I'm gonna take breaks. Yeah, anyhow, stop. Let's do this. Okay, so yeah, up and to the left. So up and to the left, and up and to the left, left, up. Oops, don't want to forget this part. I like to think of myself as being adaptable and able to learn, right? I can learn from my mistakes, right? Learn from the other mistakes too, right? I don't have enough lifetimes to make enough mistakes myself, so I have to learn from others. Okay, so this is up. Multiplied to the right. Down. To the left. Oops. To the left. Down and oops. To the right. Okay, let's see what happens here. Whoa. Small typo. Big money, no whammies. All right, let's submit it and see what happens here. Probably okay. Super verbose, but oh, wrong answer. Holy cow. Okay. Was not expecting that. Output's 8. We're expecting 10s. I'm not adding up enough. Up and to the left. Up and to the right. Down and to the left. Down and to the right. That was okay. But there's the problem. Oops. Right. Most columns built upon itself. Okay, I think that's good then. Big money, no whammies. Big money, no whammies. Okay, then I guess we can run this too. All right, do some validation. Make sure the one that failed now passes. Okay, that looks good. Submit. And then I'm gonna say goodbye to y'all. Only got two this time because Q2 is like super verbose. Oh, no way. Time limit exceeded? No way, really? Dude, y'all are like way too stringent on Kotlin, I think. It's crap. How much better can I get here? I'll just post it. It seems like a legit solution to me. Jeez. Yeah, whatever. We'll save Rust for later too. Let's do this. To do implement me. Good enough. Let's tag it. Oh, actually, I'm excited to put this in the art of DP too. That'd be cool. Let's do this. This guy over here. I'll show you all what I'm doing. Oops. Boop. Okay, so this one is performing pre-calculations, right, to reduce the asymptotic bounds in order to avoid TLE. So, oops, hold on, let's go back here. Right triangles. Stick it here. Yeah. Okay, so I should just grab this, commit it. And then we'll also go in here and update my online post. All right, stick it in here. So this comes up all the time in LeetCode, right? So if you try to brute force this thing without doing some pre-calculations for one lookups per IJ cell, it'll TLE for sure. Right, 1,000 by 1,000 is too big for brute force. Right, stick that there. All right. And I'll say goodbye to y'all for now. To be continued. This isn't the first or last time I'll make a fool out of myself on LeetCode, so catch y'all later. Have a good weekend.